right, so identifying types of functions is an important skill in algebra and in life in general, um, or at least if you study the sciences, you want to know basically how things behave in nature. And there's different kinds of behavior. There's linear, there's exponential, there's quadratic. It could be follow a parabola type shape, etc. So recognizing these function types is key, and it's pretty easy to recognize function types from their graphs, right? So this is a parabola here. So whatever this green function is a quadratic function. This blue line is a straight line, so that's a linear function. This orange function exhibits exponential growth. The higher the value of the function, the more quickly it grows, um, etc. So it's pretty easy to identify from a graph, but it's also sometimes useful to be able to identify um, functional relationships just on tables of data. And unfortunately, that's less interesting, right? But uh, sometimes, I mean, okay, so you can always graph something, but maybe you don't have enough information to produce a really clear graph. So maybe you need another way. So we're going to focus on how to identify function types, not visually, but how the data relate to each other. And so here I've got um, some. So okay, let me back up. These functions here, the linear function is y equals 2x plus 3. The quadratic function is y equals 2x squared, and the exponential function is y equals 2 to the power of x. So these functions actually do correspond to these functions here, but we're gonna make the visual just kind of sit over here for a while, and I'm gonna focus on the numbers. So I have some tables here, and I've got some x values in the function, and then I've got some y values. So this function is y equals 2x plus 3. That means if I take a value of x, what I do to get y is I multiply by 2 and I add 3 to it, and then I get the y. So I have this column of x's, and then 2x plus 3 would be these. And similarly for y equals 2x squared, I've got some x's, and then what happens if you square x and then you multiply by 2? That's y, right? Okay, so these, and then exponential function. Here's x, just some random x's, 1 through 12, just because. And then what happens when you do this to x? You take 2 and you raise it to that power. So these numbers exhibit certain patterns, and those are called add, multiply, multiply, and add, multiply. And here's what that's talking about. So, for example, add. You can notice something. Say like, as I go from 1 to 3, what color should we do here? As I travel, green, trying to show something that's, let's go back to blue. Okay, sorry. Um, Going from 1 to 3, for example, is adding 2 to the value of x. As I go to from the corresponding numbers, here, I actually need to make this darker. Um, from the output numbers, the y's, 3 to 7, that's adding 4. Well, and I'm just kind of picking out things. So if I do a similar jump here from 3 to 5, I'm adding 2 for x, and I go, I use the corresponding y values from 7 to 11 is also plus 4. From 5 to 7, plus 2. From 11 to 15, plus 4. So that's what we call the add property. As I add a constant to the value of x, I'm correspondingly adding a constant to the values of y. And I could have done like, oh, as I go from 2 to 8, I'm adding 6. As I go from the corresponding 5 to 17, I'm adding 12. As I go from 8 to 14, I'm adding 6. And as I go from 17 to whatever it is, I'm adding 12. You can pick out the jumps, just make them consistent. All right, so that's the add property. So a table of data that shows that kind of relationship is a linear function. All right, let's look at the quadratic. So let's do the same jump, like the 1 to 3 business. Um, Actually, let's do 2 to 4. Let's just do 2 to 4. So I move from 2 to 4. Um, I'm I'm multiplying by 2. As I move from 8 to 32, I'm multiplying by 4. Okay, as I move from 4 to 8, I multiply by 2. As I move from 32 to 128, 32 times 4 is 128. So it's multiplying by 4. So here the relationship is, as I take a constant multiple of x, I get a constant multiple of y. So that's why it's called the multiply multiply. So if I can find a relationship, like going from 2 to 4 is multiplying 2 by 4. Going from 4 to 8 is multiplying by 2. Uh, to check the next jump, I would have to go from 8 to 16, which I don't have. But so use the values that you have. Um, you got to pick some kind of jump that you're able to do a couple of times with the data that you have. All right, and then exponential functions exhibit the add multiply property. So if I go from 1 to 3, I'm adding by 2. If I go from 3 to 5, I'm adding by 2. Well, if I go from 2 to 8, now I'm going to have to switch colors. That's multiplying by 4. As I go from 8 to 32, 8 times 4 is 32. So as I add a constant to the values of x, I get a constant multiple of the values of y. Right. So those are the basic relationships between the input values and the export values of linear functions, quadratic functions, and exponential functions. So I gave you 4 tables of data, and so now it's up to you to figure out which kinds of patterns are shown in each set of data. Is it add? Is it multiply multiply? Or add multiply? And then use that to identify the type of function that each table represents. Now again, you could graph these data points, x coordinate is 2, y coordinate is 12, and then see what shapes come out. But maybe it's unclear from just this data. If you only have a few data points, then an exponential function and a quadratic function can look pretty similar. See how, I don't know if you can see that anymore, but anyway, but you can verify using these patterns what kind of function it is. All right, good luck.